Hello and welcome to Ignite. I'm Kristensen from the Developer Division here at Microsoft. Today I'm going to talk about some of the challenges faced by developers and organizations in a world of hybrid work, and how some of our newest products, Microsoft DevBox and Azure deployment environments, help developers have more freedom using the tools and tech they love, and help admins gain the visibility and control they need to keep the development lifecycle secure. Many developers and technical professionals have returned to the workplace, but many have not. We hear from both our customers and our own engineers that this mode of hybrid work, accommodating both in-office and remote workers, presents some new and unique challenges for developers and for IT. For developers, it's always about productivity. How quickly can I get my environment up, running, and to code? And once I start, how long can I stay in flow? We know when onboarding devs to a new project, it's always taken a long time to get set up with a new workstation. Remote devs have it even worse, since supply chain issues can make it even harder to get set up with specialized hardware. And that's assuming devs can even access the resources they need in the first place. A developer in a location with limited bandwidth can spend hours each day synchronizing code with teammates on the other side of the globe. We also know that devs don't just work on one project, they work on multiple projects, each having its own configuration, tooling dependencies, and even specialized hardware. Mixing projects and configurations on the same machine can often lead to projects config polluting another, and keeping them separate often calls for containerization or virtualization, which increases the hardware demands on your dev machine. That same dev machine is also running the local copy of the app you're working on. For a new developer taking a remote role, the reality we often hear is that all of this takes place on the laptop they received from their company in the mail. For the IT admin or the dev infra team responsible for an engineering system, it's all about enabling developers to be productive wherever they are while keeping everything secure. Different development teams and projects have different needs. A team working on an AI project may need access to GPU resources and massive sets of data, while a team working on a company's public website or web apps needs access to services that can test user experiences under load. With teams working in different locations, IT needs to ensure that dev teams have access to the resources that they need while minimizing the impact on their productivity. For companies who started the journey to remote work in the last few years, there's still a learning curve. Many engineering systems weren't designed to be self-serve or documented to reflect remote work, resulting in high volumes of internal support requests when they don't work as expected. That stretches IT teams thin, and it means developers have less time to spend coding. All of this additional complexity and geo-distribution makes engineering systems ripe targets for malicious actors. We've already seen many examples of software supply chain attacks. IT needs to be able to keep up as new threats emerge and push updates across their organization, no matter where those endpoints are. Few organizations have the resources to build a solution that addresses these challenges for their dev and intra teams. That's why, at Build earlier this year, we introduced Microsoft DevBox and Azure deployment environments. These two services pair together to give developers a complete cloud-powered workflow for any project that can be fully managed by admins. DevBox offers developers high-performance, cloud-based workstations that help them be ready to code for any project in minutes. Azure deployment environments enables dev teams to spin up the infra they need for their project in the cloud quickly and on demand. Whatever you can define in ARM templates, you can replicate in deployment environments. With built-in project templates and strong integration with Azure's policy and security controls, these two products enable dev teams to be productive while helping admins keep those resources secure for the entire organization. Let me show you what that looks like. Let's say I'm a developer just starting my workday. Depending on what solution I'll work on, I'll go to devbox.microsoft.com and select which devbox to connect to. I can also easily create new ones. Each devbox I've created are uniquely equipped to handle the various solutions I develop and maintain for as part of my job. For instance, I work on our podcast app, but also sometimes must maintain an old legacy codebase. With DevBox, I can freeze my environment in time with old SDKs and components required to work on the legacy app without those configurations polluting my other DevBoxes or my laptop, which I'd like to keep up to date with the latest of everything. They also show up in the remote desktop app, which is available for Windows, Mac, and more. I'll connect to the podcast DevBox. It has everything I need to work on the podcast app. I also have access to all my documents because OneDrive seamlessly synchronized them. It truly feels like just another one of my PCs. And with Azure deployment environments, I get my own copy of the services needed for my solution to run, but without using my own Azure subscription. That way I can reconfigure those services as needed without impacting my colleagues. The best part is that I can sit outside on my laptop with battery power all day long, since all the heavy lifting like compiling and debugging, etc., is all handled in the cloud. This is a .NET multi-platform app that we built for last year's .NET conference. In a single code base, it targets iOS, Android, Windows and Mac, mobile and desktop, all with .NET and C# code. The best way to understand a .NET MAUI app is by looking at the project file. You can see that we're using .NET multi-targeting to target the different platforms, iOS, Android, Mac, and Windows. You can also see that our app title and versions are all set in one place. Additionally, the splash screen, app icon, and more are all shared across the different platforms from these lines of code. If you want to write custom code for the platforms, you can use compiler directives, ifdefs, right within your C#, or you can create custom files within each platform's platform folder that houses all the different files necessary for the platform to run your app. One of the really cool things about MAUI is that you can also share any non-code resources across the app. In this application, we're sharing fonts, images, styles, and even strings along with our app icon and splash screen. You can upload one SVG or PNG for any image in your app, and MAUI will scale it to the correct resolution for your device that the app is running on automatically. MAUI is just a .NET project too, so it's taking advantage of the program startup pattern you're familiar with in ASP.NET, as well as all the latest and greatest C# features such as global usings. So let's take a look at the app by actually running it now. This is the target framework selector, so I'm making sure I have Windows selected and going to hit F5 or click this here to run it directly on my DevBox on Windows. The podcast app is meant to help you discover podcasts about .NET. You can click into them for details, subscribe to them, and listen to each episode. Because I'm remoted into my DevBox, I only have one monitor that I'm working with. It can be annoying to click between the app and the IDE when I want to make code changes. So let's use this thing called Live Preview. You can open the SAML Live Preview window through the debug Windows SAML Live Preview command if it doesn't automatically pop up for you. SAML Live Preview helps you find and inspect parts of your app's UI. As I hover over different elements, I can see their render size, color, and where they are defined in my SAML files. If I click on them, it takes me to the exact line they are defined on in the SAML files. So this grid is defined here. And then I can click into these titles here and it will pop me to where they are in the SAML. Let's make some edits here. I want to change the font color. So I will start typing, and IntelliCode knows right away that the change most people want to make to a label is text color. Let's set it to fuchsia. And immediately, the change is reflected in my running app using SAML hot reload. You can use any architecture you want with .NET MAUI, but most people use MVVM, or Model View View Model. A key part of MVVM is data binding. Sometimes you spell items wrong, or accidentally delete things, and then parts of your UI don't show up. Using data binding diagnostics, you can see if there were any failures in the data binding, and then click into the window here to have it bring you to where in your SAML the issue is. Then you can quickly resolve it. Another way to inspect the UI of your app is using the live visual tree, which shows you all of your UI elements in a visual hierarchy. For example, I can click into the top-level navigation of my app and see that there is an image we use for the header in the flyout. And if I click on the two arrows, it will take me right to it. Let's take a look at this app on a different platform, Android. Using the Windows subsystem for Android, I'm able to connect to my VS instance and debug the Android version running directly on the dev box here. I could also use the Android emulator if I prefer. I have all the same tooling I had on Windows, just now it's the Android version of my app. You can tell because I have bottom tabs here. The way we wrote this app was so that on desktop you navigated with a flyout menu, and on mobile you navigated with tabs. I can resize it to look a bit more phone-shaped too. I still have my live preview and hot reloads too. But I can hot reload more than just SAML code. Let's say I want to add a button to this settings page. I'll start typing my SAML. IntelliCode is super helpful here. And I'll also add a click handler. But my click handler needs to be defined in C#, and it doesn't currently exist. Visual Studio tried to add a blank one for me, so let's go look at that. I want my click handler to show a little pop-up, so let's make this async, and then start writing out my display alert with a title, description, and cancel text. And then click into the SAML to make sure it's all good. Then let's open back up the Android app, click the button and voila, hot reload. So that was pretty cool. And by the way, this is all running seamlessly in a dev box. But this is just a few of the podcast clients. So far, we've worked on the podcast app client for Windows and Android, all sharing common code thanks to .NET MAUI. But there's also a web app, as well as a backend running on containers with databases and storage for different podcast feeds and analytics. That's what's powering the data coming through to the app. It's a pretty massive app, and we'll show you how that's running in a bit. But for now, let's take a look at the website part of the solution. I've got multiple solutions in this repo, so I'll click this button on the Solution Explorer toolbar to show them all. Let's run the website in the browser. The site looks great on my desktop, but I mostly use my phone to browse the web these days. So how do I actually test it on a physical phone before I commit my changes? Notice the URL in the browser. It's not localhost. Instead, it's being served through a secure dev tunnel, which allows me to hit my localhost from anywhere. I'll use my browser's ability to convert a URL to a QR code and take a picture of it with my phone. Just point the camera to open the URL on your phone. The website running on my local host is now available for me to test on my phone or any other device. This connection can be either secured behind an organizational login, private, or public. No cables or custom apps installed for this to work. Back in Visual Studio, I remembered that I was supposed to add a README file to the client project. I'll right-click the project and select Add New Item. This brings up the new Quick Add dialog, but I still have access to all the templates that I'm used to. But going back to Quick Add helps me add files much faster. Let's say I want to add two files, iClient.cs and client.cs. I can type multiple file names separated by a comma, and they're all added to the project. Notice how client.cs is a C# class, whereas iClient.cs is an interface. The Quick Add dialog knows how certain naming conventions map to the existing templates and can choose the right one for the job. It can also add folders. Just type the name and end it with a /. But let's go back and add our README file. I'll create a new folder named Docs and add the readme.md file in it. Quick Add makes that super easy. I'll paste in my markdown text from the clipboard. Notice how I'm getting excellent syntax highlighting for markdown files now. Let's open the preview window so we can see what the rendered markdown is going to look like. This helps me make sure it looks great before I'm committing this to GitHub. And of course you get all the convenient features such as scroll synchronization. Now it's time to commit these changes. So let's head into the Git Changes window and start typing our commit message. This commit will fix an open issue on the GitHub repo, and I can now see all the issues show up directly in the text box after typing the pound character. This works for Azure DevOps items as well. And if you don't remember the issue number, you can type part of the title to filter the list. So now all there is left is to commit and push the changes to GitHub. Whenever I make a commit, a GitHub action runs my CI workflow. It builds everything, then runs the unit tests, playwright tests, and Azure load tests. The cool thing about the load tests is that I can make sure that my commits won't degrade the performance of the app. Running the load tests in the Azure deployment environment makes sure it doesn't interfere with any other tests currently running by my team members. It keeps it completely isolated. So, in that demo, you saw how Microsoft DevBox gave me a seamless, high-performing development experience while using new features in Visual Studio 2022, like our MAUI tooling that helps me stay productive and secure dev tunnels that help me collaborate from anywhere. And all the backend services my app communicates with are running in their own sandbox thanks to deployment environments. And when it was time to validate my changes, load testing was already built into my CI pipeline to ensure my changes don't cause issues when the service is under load. What's important about DevBoxes and deployment environments in that last demo is what I didn't have to show you. The DevBox was up to date, it was connected to company resources, and also connected to a sandboxed copy of the app running for development. DevBoxes work with the tools developers love, whether that's Visual Studio, VS Code, or another IDE. It's a full machine for whatever you need. And you can provision them for any type of workload, from cloud services to .NET MAUI apps. It all just worked, and that shows just how seamless the DevBox and deployment environment experience is for developers. The key to making that experience seamless for developers is how DevBox and deployment environments allow management for project admins to configure these services for their teams. So what do DevBox and deployment environments look like to the user setting it up? I'll now switch roles to take you behind the scenes on what these tools look like for IT and project admins. For admins to get their team set up with Microsoft DevBox, they utilize DevBox definitions and network connections, which are resources in the Azure portal. Admins create DevBox definitions, which contain the hardware specs and the software images that contain the right project dependencies. These can be Windows 10 or 11 images from the Azure Marketplace, or they can be custom images from your own Azure Compute Gallery. We've even provided developer base images that include Visual Studio pre-installed. Network connections define the regions available in which DevBoxes deploy, making it easy to support remote teams around the world with a high-fidelity experience. They also define how those DevBoxes connect to your network and how they can connect to Azure Active Directory so you can apply policies, manage, and monitor them through tools like Microsoft Endpoint Manager. With these defined, admins create projects for their teams with pools of DevBoxes to match the needs of each of your projects. Now I'll go back to a demo to show you what this looks like through the eyes of an admin. While developers interact with DevBox through a specialized dev portal or the remote desktop client, as an admin, I manage DevBoxes through the Azure portal in a resource called a Dev Center. The Dev Center is what brings all my resources together, DevBoxes and environments. Let's create a new Dev Center just to see what that looks like. I just need to name it and assign it to a resource group and a region. Within my Dev Center, I can create the DevBox definitions our team needs. In the Dev Center, I go to the DevBox Definitions page and click Create. Definitions combine the software image for the DevBox with hardware resources. I can create ones for specific projects or parts of a project. I can leverage the built-in set of images, or I can upload a custom image that includes other apps like profilers and emulators, the codebase, developer tools, and everything else needed for the project. Versions ensure I can freeze the box version or ensure that when the underlying image gets updated, all DevBoxes automatically get moved to the latest patch. I can also select the relevant hardware SKU the DevBox will deploy with. Working on the podcast app isn't going to be particularly compute heavy, since the app will be running in the deployment environment, so I can choose a SKU with a moderate amount of compute. I could always create another DevBox definition with more resources for scenarios that need it. Next, it's time to define network connections. Network connections give you fine-grained control over the resources DevBoxes can access on your network. They also define how those DevBoxes are managed. I want these machines joined to an Active Directory, which ensures that as an admin, I can apply policies and monitor health of the DevBoxes from Microsoft Endpoint Manager. You'll see more of that in a minute. I define these connections once and can use them across different groups of DevBoxes or projects. Now that we have defined our templates for our DevBoxes, we can create projects for each team to have their own space. Projects help organize access control. They belong to your Dev Center and are containers for creating pools of DevBoxes. This segmentation allows us to provide multiple teams with the same DevBox components while tailoring an individual developer's experience to just the DevBox they need. In my project, I have roles and role assignments for my teams. I can add myself here, or more likely I'd have an AAD group for my team that has role assignments to DevBox users and myself to Dev Center Project Admin. Dev Center Project Admins have the freedom to take the DevBox definitions and network connections we just made and combine them into DevBox pools based on the needs of their team. Dev Center Project Admins can also manage memberships to the project, adding and removing devs without needing support from IT. DevBox pools are where we bring this all together. As a Dev Center Project Admin, I go to my project, navigate to the DevBox Pools page, and click Create. To add a new pool, here I can select the DevBox definition and network connection I already created earlier. Our DevBox pool is now created, and developers assigned to the project can now start creating DevBoxes. I mentioned before that because these DevBoxes are AAD joined, I can easily manage them. DevBoxes are managed using Windows 365 or Microsoft Endpoint Manager. You can ensure all your standard apps and tools get installed like any other enrolled device. All your organization's policy settings will get deployed, and they get the latest Windows updates to ensure they're always up to date. As an admin in Microsoft Endpoint Manager, you can set conditional access policies like multi-factor authentication, and you can ensure everyone connects to the service using a compliant device that meets your enterprise standards. You can configure these settings not only by user, but also DevBox type, giving you the freedom to manage and secure your DevBoxes in the way that works best for your organization. We showed how, as an admin, I created pools of custom DevBoxes for my team to use based on the projects they're working on and each project's hardware needs. You remember that the back end of the podcast app was running in an Azure deployment environment. I can provide devs access to the environments I maintain for dev, test, and staging to spin up these resources. But working with individual devs every time they need a new environment is incredibly time-consuming and unsustainable. At the same time, I can't just give devs unlimited access to organization subscriptions, nor do I want them navigating around the Azure portal. That's where deployment environments come in. Dev and test environments are critical for developers working on complex modern applications, as these applications rely on multiple cloud services to run, as well as supporting services like Azure Key Vaults. There are two primary things Azure deployment environments does to solve these challenges. 1. It enables developers to deploy environments without needing access to the subscriptions where they live. And 2, it enables developers to reuse the same template to spin up all resources needed for the project. Let's see what that looks like for the admin. It's all back to the Dev Center. You can see between my DevBox configuration and my projects, I've also got a section for environment configurations. Let's take a look at catalogs first. Because I don't want developers spinning up random resources without any supervision or oversight, I can control what developers can deploy by providing them with infrastructure as code templates. Let's see what that looks like. I can store these templates in a GitHub or Azure DevOps repository, which helps with versioning and visibility across my organization. The repo consists of ARM templates that define the apps and services that my developers are working on. I point my Dev Center to this repo, and each app or service that's defined becomes an item in our catalog. By storing the template source files in a repository, developers can easily collaborate on the ARM templates, adding in their own tweaks and collaborating with the rest of the team to establish and share best practices. At the same time, the templates remain subject to regular checks, and I can maintain visibility and oversight over the changes. By connecting the repo where this catalog lives to the Dev Center, Azure Deployment Environments automatically scans for these file types and adds them as catalog items available to the developers on the project, and can create or delete them via actions, pipelines, or the CLI. Finally, environment types help ensure that each copy of the app or service that's running is running with the right set of resources, policies, and cost control. I don't want my developers accessing Azure subscriptions directly, so I can create environment types and map them to the appropriate Azure subscriptions. I can create an environment type for each stage of development: development, testing, sandbox, pre-production, or production, and map them to my subscriptions. Not only does this ensure devs deploy resources to the right environments, it also makes it easy for me to understand billing and audit the resources being created by various development teams. I can also establish specific settings and policies for each of these environment types, managing things like security and permissions. For instance, I can limit the permissions a developer has in a production environment while giving them more freedom to experiment in a sandbox environment. As we all know, not many things disappoint customers like a slow website, or worse, a website which starts behaving poorly under load. Your developers need a way to determine if the code they wrote will scale to the expected load and even understand the behavior when their solution is under extreme spikes of unexpected load. With Azure load testing, your developers can generate high-scale load with ease, simplifying load tests and unlocking the full potential of Apache JMeter. These tests integrate with their CI/CD pipelines in either GitHub Actions or Azure pipelines. Let's set it up in the Azure portal. Your first steps will be opening the Azure load testing service and creating the resource. Select the resource group, create a name for your load testing instance, and the location for this resource to run. Select Create once you have defined the key attributes for your Azure load testing resource. As the service is being created, the deployment will begin immediately. Now that the load testing resources have been deployed, you and your team can do some quick tests to validate everything is working as expected. Work with your development teams to have this information to set up the initial load testing quick test. While the quick test is a great way for initial evaluation of load testing, your developers will really want to unlock the power of Apache JMeter. For this, you can create a load test by uploading a JMeter script provided by your development team. To create this load test with JMeter scripts, you simply upload the JMeter script and set the details for the test plan, the parameters, and the monitoring resources which should be involved within this load test. Once you have updated these details, you simply create the load testing resources, which can then be integrated right into your developer's pipeline through their GitHub Actions or Azure Pipeline's YAML files. Your developers are enabled to call these load tests throughout multiple stages of their code flows. The ability to execute load tests in pre-production or staging environments is now easy for your developers, as they can integrate the load tests earlier in the pipeline and targeting different environments. You just saw how admins can set their teams up with DevBox and deployment environments to enable the developer scenario in the first demo, while having granular control over the resources used and ensuring that they're secure and compliant. Microsoft DevBox is in public preview today, so you can start using it to create secure, cloud-based workstations. DevBoxes can be accessed from the browser or remote desktop clients for Windows, Mac OS, and even Android and iOS. We've also released new base images on the Azure Compute Gallery that include Visual Studio development tools that you can use as a base for whatever project you want to work on, and make sure your developers are always working on the latest tools. Azure Deployment Environments is also in public preview to manage the environments your teams are working with, while also helping keep them productive. We're excited to see how you'll start using both these services and can't wait to hear your feedback. There's much more innovation coming in the future. You also saw some of the new features for developers we have in the latest version of Visual Studio. The Visual Studio 2022 version 17.3 is generally available today and includes GA of capabilities like the MAUI tooling you saw, improved Git and GitHub integrations, and the architecture changes to 64-bit. We also have a new preview of 17.4 available today, and some of the features you saw, like dev tunnels, are coming as part of 17.4. We believe that all of these tools and services fundamentally transform what developers can do and how they can be more productive to use the tools and tech they love in a world of hybrid work. Thanks for joining, and have a great Ignite.